question that we did yesterday that I gave like 5 stars beside and said it's really important. This is the exact same question, but now instead of giving you a domain in degrees, we can do all the same questions that we've done in trigonometry our entire lives and make them grade 12 questions by just saying, let's do it in radians instead of degrees. So this question's in radians. If this question was in degrees, the domain would say from negative 360 degrees to 360 degrees. And you might remember that when I got you to think about this, I said, think about your positive ones and your negative ones separately. So now I'm going to erase the 360. And change that to 2 pi, because now I'm thinking in radians. So how did we do this question when it was in degrees? We started by drawing a picture and trying to find a triangle, because we're looking for trigonometry. So if I drew a picture of this, the point negative 4, comma 3, is on the terminal arm of an angle in standard position. So I can always go back to my nearest x-axis and draw a right angle triangle. By going back to my nearest x-axis, I make my reference angle, and I know that this height is 3 and this length is 4. What do I want to find? I want to find the angle in standard position. The positive one would look like this, starting from the positive x-axis and going to that angle. So that's the angle theta, the positive one at least, that I'm looking for. Well, how would I find that? First, I need to go back to my grade 10 math and find my reference angle. The difference, though, is that instead of having my calculator in degrees, I now have my calculator in radians. So I would write that tan of my reference angle is opposite over hypotenuse. Then I go to my calculator and I would do second tan inverse of 3 divided by 4. And instead of getting an answer in degrees, I get an answer in radians. But it's exactly the same idea. The only thing is that your brain doesn't like this number. Right? 0.6435 is like, what does that mean? If it was 30, I think it's like 37 or 39 degrees, your brain would be like, bing, I see 37. It doesn't see 0.64. You can't, if I said, show me with your hands, what does 1.32 radians look like? Probably what would happen. You'd be like, I don't know. But if I asked you with your hands, could you show me 100 degrees? You'd be like, okay, I think I can do that. So we're just not used to radians yet. So we got 0.6435. Everything is the same as what you would do in degrees. If you wanted to find this blue angle, and we were dealing in degrees, and the reference angle was 37, do you see that you would do 180 minus 37 degrees? Now that we're in radians, instead of 180, halfway around will be pi radians. So we're going to take pi radians and minus our reference angle. Something that's going to be helpful on your calculator, all calculators have a memory button. If you can find out where yours is, it's great. With the graphing calculator, the memory button is called store, and it's right above the on button. So if I hit the store button, it says, where would you like to store your answer? And I can choose, like, There's letters, A, B, C, D. I can choose any letter I want, or I often just like using the X button and store it as X. So now my calculator says, whenever I push X, it's going to remember 0.6435. So for example, if I went, ooh, what's X plus 1? Oh, 1.6435. Makes sense. What's nice about this is I can figure out that the angle, pi minus my reference angle, instead of having to retype all those decimal places or highlight it, I can just go pi minus x, and I get 2.5 to the nearest 10th. So this angle, the blue one, is 2.5. The red one, we also need to think negative. So negative in standard position, also starting here. But that would go in that direction. If it was in degrees, I would do 180 degrees, which get me up to here, plus my reference angle. Whatever number I would get, then I would make it negative because I'm going in the other direction. So the same thing in radians. I'm going to go halfway around is pi. I'm going to add my reference angle to get to here. Whatever answer I get, I'm going to put a negative in front of that. So I'm going to go to my calculator here. I'm going to say, well, I'm going to take pi plus x, because that's my reference angle. I get 3.8. So this one will be negative 3.8. So now we have our answers in radians instead of degrees. We really need to know our process from grade 11 math well, because as soon as your brain switches to a material like radians that you're not as used to, your regular steps become harder unless you know them really, really well. So I hope you notice here that the steps are the same whether you do degrees or radians, but now it's harder because you're dealing with something you're not used to. Same thing, part B is just like a question that we did in degrees. In fact, we did 2 of these the other day, so hopefully when we do a third one here, this time in radians, you remember what we did last time. So last time, we would have started with cotangent of theta equals -2, so you would know that tangent of theta is the reciprocal 1/2. Notice the angle didn't change, but the ratio did get flipped. If I have tangent equals 1/2, next I would think about my cast rule and say, if tangent is negative, it can't be in quadrant 1 and it can't be in quadrant 3. So tangent is negative in quadrants 2 and quadrants 4. And I can draw a picture of the angle in quadrant 2 and draw a picture of the angle in quadrant 4. In both situations, I can go back to the nearest x-axis, which lets me label my reference angle. And since tangent is the opposite over the adjacent, I can label those 2 sides. And this allows me to find my reference angle. Right, tan on my reference angle, opposite over opposite over adjacent, right? Little reminder, this is a common mistake. When you see tan theta equals -1/2, people want to find their reference angle with -1/2. When finding the reference angle, we're always dealing with positive values because you're going back to grade 10 math and you're thinking, I have an actual triangle with actual lengths. My reference angle then can go to my calculator. tan inverse of 1 divided by 2, 0.4636. And you'll often see me when I'm doing my work by putting dot, 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 which means I'm not rounding early. Rounding early can sometimes cause your final answer to be off. I don't want to round early. In fact, just like the last example, I'm going to store this as x. And now my x is another number. Just replace the previous number it was. Because I'm going to use this reference angle a lot. Let's look at our domain. I found my reference angle. The domain, again, is from negative 2 pi to 2 pi, so we have to split it up. Split our positive values and our negative values up. So our positive ones looking from 0 to 2 pi, negative from 0 to negative 2 pi. So let's draw those arrows in on our pictures. The positive ones. Starting here in the positive direction, this would be 1. This would be the other one. If I was thinking in degrees, I would do 180 minus my reference angle. Now I'm thinking in radians, so it'll be pi minus my reference angle. Go to my calculator. Pi minus x, 2.7. Did it say the nearest tenth? Read it again. Yes, nearest tenth. Second answer, in quadrant 4, I would go all the way around, which is 2 pi, and then minus my reference angle. So once again, I go to my calculator. 2 pi minus, and I stored my reference angle as x, so I get 5.8. My negative angles, from 0 to negative 2 pi, these would be our two angles. I hope you can see the quadrant 4 one is the easiest. If you know your reference angle is 0.46, then quadrant 4 would be negative and rounded to the nearest tenth, negative 0.5. The angle in quadrant 2. If I was thinking about this in degrees, I'd go 180 plus my reference angle. In radians, I'll go pi plus my reference angle. Whatever I get, I'll make it negative. I go to my calculator. Pi plus my reference angle, 3.6. So that angle will be negative 3.6. Again, put 5 stars beside this one, because these questions come up a lot. What's different from grade 11 is we're dealing in radians now, and we also could go past 0 to 360. We could go more times around or less times around. But it's kind of nice because you're getting a good review of what you did in grade 11. Some of this stuff you've probably forgotten. And now just adding a little bit of what's in grade 12 here. So we have about 8 minutes left in class. I want you to try questions 13 and 14.